Hello and welcome to the final video of our Year 9 Surds series. Today we'll be talking about rationalizing the denominator, and so the term rationalizing has the term rational in it. And so when we're rationalizing the denominator, we're simply trying to make the denominator, change it from something like a surd into a rational number. So let's dive straight into it. So let's consider the expression 4 root 2. So in general, we don't want a surd in the denominator. It's just too hard to deal with, and we don't really know the exact value of a surd. So how on earth do we get rid of the root 2 in the denominator? Well, in this case, the best way to do so would be multiplying by root 2 over root 2. Now, why is that the case? Well, in this case, it's because root 2 over root 2 is simply equal to 1. So I'm not changing the value of my fraction. But what I am doing is getting a numerator of 4 root 2, and then getting a denominator, root 2 times root 2 is simply 2. And then I can further simplify this to say it's equal to 2 root 2. So hopefully you can see that by multiplying the top and bottom by the same surd, we were effectively able to get rid of the denominator being a surd. So let's try and apply this to a few more examples. So consider the expression 4 on root 5 plus root 5 on 4. Can we simplify it? So at first, it looks like we can't simplify this any further, right? It doesn't look like they're like terms, so we can't collect anything. But actually, we can. So let's figure out how to do this. Let's first simplify this 4 on root 5. So the 4 on root 5, we can simplify and multiply by root 5 over root 5. The reason I do this is because the denominator then just becomes 5, and the numerator becomes 4 root 5. So this first fraction is 4 root 5 on 5. So can we simplify this expression now? Well, the expression now becomes 4 root 5 over 5 plus root 5 over 4. And now what we can do is start doing the cross multiplication. So 4 times 4 root 5 gives us 16 root 5, plus 5 times root 5 gives us 5 root 5, and then our denominator becomes 5 times 4, which is 20. So we get 16 root 5 plus 5 root 5, which is just collecting like terms. So we get 21 root 5, and then 21 root 5 over 20. And that is going to be our final answer. So you can see we were able to simplify it. It just didn't look like it when we saw the question at first. So here are a few quick, easy examples. So pause the video and have a go through all 4, and then unpause so that we can go through the solutions. So with question 1, there's actually 2 different ways we can do this. The first way we can do this is by far the simplest and the most straightforward way, and that would be to multiply the top and bottom by root 10. So if I just go root 2 on 3 root 10, and I multiply by root 10 over root 10, that's going to give me root 20 on the top, and then give me 3 times 10, so 30 on the bottom. So then we simplify the root 20, and we know from our simplification video that the root 20 can be written as 2 root 5. And so 2 root 5 over 30 is equal to root 5 over 15. Now, the other way we can do this, so we'll call this method 1. Now, the other way we can do this is actually look at the question before we actually proceed any further. Root 2 over root 10, we can actually simplify that to 1 over 3 root 5. The reason for that is because surds work just like normal numbers. So 2 over 10 becomes 1 over 5. So root 2 over root 10 becomes root 1 over root 5. And so that's why we get 1 on 3 root 5. So then we can actually multiply by root 5 on root 5. And so we end up getting root 5 on the top. And then on the bottom, we get 3 times root 5 times root 5, which is 3 times 5, which is 15. And so we get the answer quite quick. We don't actually have to do all this simplification. So that's method 2 over there. You might be wondering why I didn't multiply by 3 root 10. to top and bottom. And the reason for that is because the 3 isn't really going to help us. It's already a rational number. So we really just want to multiply the top and bottom by the irrational parts. So with question 2, we would want to multiply top and bottom by root 5. So I'll just multiply by root 5 over root 5. That gives us root 75 on the top, and then 3 times 5, so 15 on the bottom. We know that root 75 simplifies to 5 root 3, and so we get 5 root 3 on 15, which is equal to root 3 over 3. So we'll call that method 1. Method 2, we actually didn't even have to do all this rationalizing. We already know that root 15 over root 5 is going to be root 3, because remember 15 on 5 is 3, so root 15 on root 5 is 3. So we just get root 3 over 3, and that would be our final answer. So depending on whichever method works best for you, use it. Moving on to question 3, we have 1 on root 2 plus root 2. Now, it's important here that we want to get a common denominator. So either we can make the root 2 have a denominator of root 2, or we can first just get this as a rational denominator. And I think it's best if we make the denominator for the first fraction rational. So if with the 1 on root 2, I would multiply the top and bottom by root 2. So I get root 2 over 2, because remember, root 2 times root 2 is 2. So I'm left with root 2 on 2 plus root 2. Now we know that root 2 is equal to 2 root 2 over 2, because it's still equal to root 2. And then we can say we have a common denominator of 2. That means we can add them together. So root 2 plus 2 root 2 is simply equal to 3 root 2. And so 3 root 2 over 2 would be our final answer. And finally, we have question 4. You can see we have a denominator of root 3, and 2 root 3. So the common denominator here might be 2 root 3. So if I'm to make this first fraction root 3, to make this a common denominator, I would want it to be 2 root 3. So I'd multiply the bottom by 2, which means I have to multiply the top by 2. I would do the same thing for the next fraction. So to make this 2 root 3, I would have to multiply the bottom by 2 and multiply the top by 2. So 4 times 2 is 8. And then I don't need to change the last one because it's already got the common denominator. So now I can add them together. So 2 plus 8 plus 9 is 19. So we have 19 on 2 root 3. And then, like I said, just multiply the top and bottom by root 3 to rationalize the denominator. So 19 on 2 root 3 times root 3 on root 3, which is equal to 19 root 3 over 6. And that would be our final answer. So far what we've been looking at is rationalizing the denominator where the denominator has one surd term. But let's consider the expression 1 on root 5 minus root 3. So here we don't want surds in the denominator. So how on earth can we rationalize this? Well, here we want to be thinking about our difference of squares. So let's just consider something like root 5 minus root 3. And let's say I multiply this by root 5 plus root 3. Using our difference of squares, remember this is the same thing as just a minus b times a plus b. And we know that this was equal to a squared minus b squared. So in the same way, we can say, well, this is equal to root 5 squared minus root 3 squared. Now, root 5 squared we know is equal to 5. And we know that root 3 squared is equal to 3. So we get 5 minus 3, which is 2. And seemingly, I've sort of converted this surd that has 2 parts to it into a rational number. Now, what did I have to do that, though? I had to multiply by root 5 plus 3. And this is what we call the conjugate, okay? So just a quick bit of theory on the conjugate. If you have root x plus root y, then the conjugate of that would be root x minus root y. And if we had root x minus root y, then the conjugate of that would be root x plus root y. In fact, I might just write out what conjugate is spelled like. So let's actually have an attempt at this question now and multiply the numerator and denominator by the conjugate. So we have 1 on root 5 minus root 3. And I want to multiply the top by root 5 plus root 3, which is the conjugate. And I also want to do that to the bottom. So I haven't actually changed the value of my fraction. So now it's a good idea to use brackets. Sometimes a lot of kids get confused if they don't use brackets. So root 5 minus root 3 times root 5 plus root 3. Remember, we just said is difference of squares. So 5 minus 3. Technically, I could just go straight to the line of 2, but I'll leave that there for now. The top is just 1 times root 5 plus 1 times root 3, which is root 5 plus root 3. And so my final answer would be root 5 plus root 3 over 2. And that is how we rationalize denominators containing two surd terms. So here are a few easy examples. Pause the video and have a go, and then unpause so that we can go through the solutions. Okay, so for question 1, we want to think, what is the conjugate? Well, the conjugate of root 2 plus root 3 is going to be root 2 minus root 3. So we are going to write 1 on root 2 plus root 3 times root 2 minus root 3 over root 2 minus root 3. Might want to add some brackets to make this nice. Now, let's do the numerator because it's quite easy. 1 times root 2 minus root 3 is just going to be root 2 minus root 3. And our denominator is difference of squares, remember? So it's the first term squared minus the second term squared. So I'm going to show full working for this example, but for the next ones, I'm not going to do that. So we're going to have root 2 all squared minus root 3 all squared. The top stays as root 2 minus root 3. Now, root 2 squared is just 2, and root 3 squared is just 3. So we're left with root 2 minus root 3 over negative 1. Now, we know that if we're dividing by negative 1, everything just turns into a negative. So this would now become a minus root 2, and this minus root 3 would be a plus root 3. So our final answer would be minus root 2 plus root 3. And we could technically write this as root 3 minus root 2. It doesn't really matter. It's just the order. And for question 2, we're going to do something similar. Multiply by the conjugate. So we have 1 on root 5 minus root 7. And we multiply top and bottom by root 5 plus root 7 because that is our conjugate. And then might use brackets just to avoid any confusion. And then on the top, we have root 5 plus root 7. And then on the bottom, we have first term squared, which is 5, minus second term squared, which is 7. And so our final answer is root 5 plus root 7 over minus 2. Most people like to write the minus in front or like on the numerator. So it might be a good idea to just write it like this. And that would be our final answer. And the last example of this theory video is simplifying 7 over root 3 minus root 5 all squared. So pause the video and have a go, and then unpause so that we can go through the solution. Okay, so for this kind of example, we really just want to start by expanding the denominator and then seeing if we can get those two surd terms and then multiply by the conjugate. So let's quickly simplify this first. So we have 7 over, now the square, remember this is literally the a minus b all squared formula, which gives us a squared plus b squared minus 2ab. So following that, we can say root 3 squared is just 3, root 5 squared is just 5, and then we're minusing 2 root 3 times root 5, which simplifies to be 7 over 3 plus 5 is 8, and 8 minus 2 root 15. Now, what is the conjugate of 8 minus 2 root 15? Well, the conjugate is going to be 8 plus 2 root 15. And so we're going to multiply the top and bottom by 8 plus 2 root 15. So just do that now. And like always, we should use brackets just to make things easier for ourselves. And so the denominator is going to be difference of squares. So 8 squared is just 64. And now 2 root 15 all squared, right? So 2 squared is 4, root 15 is 15. So that means 4 times 15 gives us 60. And so we're going to get a minus 60. And on the numerator, we're going to get 7 times 8, which is 56. And then 7 times, so remember, it's just like this, 7 times 8, 56. And then 7 times 2 root 15, which is 14 root 15. And so we get 56 plus 14 root 15 over 4. And we can simplify this one more time because these are all divisible by 2. So we get 28 plus 7 root 15 over 2. And that would be our final answer. So that's all for this video. It's our last theory video of Surds. In the next video, we'll be looking at the homework questions and going through the solutions. So catch you there.